Hey guys, welcome back to Chemquiz TV. Good to have you back. So let's focus on Faraday's laws of electrolysis. And we're going to focus on the calculation aspects. So many of you have been asking me to put this video on Faraday's laws of electrolysis, and I've done my proper research. And this is going to be one of the best videos I'm going to see when it comes to what Faraday's laws of electrolysis. I want to focus on the first law. We're going to focus on Faraday's first law of electrolysis. I'm going to give you all the formulas you can use to solve questions regarding Faraday's first law of electrolysis. I'm going to give you the formulas. I'm still going to show you how to solve questions using this formula. Now, this aspect, this Faraday's first law is one confusing aspect so many students have issues with. But in this video here, you want to learn and master how to solve questions. You're not only going to learn and master. I'm going to show you how. I'm going to give you like 15 to 20 questions to solve using this formula. So by the time you finish watching this video here, you'll be able to solve some questions you're going to see in your JAMB examination. Please don't skip this video because this is going to be your total solution. So now let's get into it. So but before we continue, if you're not subscribed to the channel, please hit the subscribe button so I can join the community. I try to get to 5,000 subscribers as soon as possible. So you can help us to achieve that by liking, subscribing, and sharing this video, and also commenting is very important here. So let's get into business of today. Therefore, Faraday's first law of electrolysis. What is Faraday's first law of electrolysis? Faraday's first law of electrolysis state that the mass of a substance deposited during electrolysis is directly proportional to the quantity of electricity that passed through the electrolytes. I'll go back again. The mass of a substance deposited during electrolysis is directly proportional to the quantity of electricity that passed through the electrolyte. So from there, that's going to be our key foundation. Keyword foundation. Now, for the first law, the mass of a substance deposited during electrolysis is directly proportional to what? To the quantity of electricity that passed through the electrolyte. So M is what? Is the mass. G is what? Quantity of electricity that passed through the electrolyte. Now, if you should remove the sign of proportionality here, you are going to introduce a constant. So you're going to be what? M equals to what? K Q. And this K is chemical equivalent. Chemical equivalent. So it is be changed to Q to Z. So K is equal to what? Z. So when you're solving Faraday's law of electrolysis, you don't actually use K, you use what? Z. Z means what? Electrochemical equivalent. Yes. Z means electrovalent. Z means electrochemical equivalent. Electrochemical equivalent. So it's going to be M equals to what? Z Q. So now this is what is the first formula. So we have to place it here. M equals to what? Z Q. Where M is what is the mass, Z is what electrochemical equivalent, Q is what is quantity of charge, either or quantity of electricity. So this Q is also the same as I T, either. So quantity of charge is equal to what? Current times time, either. Current times what? Current times time. So I is what is current, I. So place here, I equals to what? Current. And current is measured in amperes. In what? In amperes. Current is what is measured in amperes. T is what? Is time. And the measure in what? In seconds. Very important. The measure in what? In seconds. So that is here I can just say M equals to what? Z I T. This is that. So this is what the first formula you want to master here. I will teach you how to solve this here. You can use this one when electrochemical equivalent is being given to you in that question. Do you get that? When electrochemical equivalent is being given to you in that question, I'm going to show you how to solve problem when it comes to that. Now, the next thing you want to look at is what is the general formula for what Faraday's first law. Now, Faraday's first law have what general formula, and the general formula is what? Mass equals to what? The molar mass of the substance deposited times what? Times Q over what? F over what? Q F. Now I'm going to break this one down for you. I'm going to break it down for you. So let me wipe this place out. M is also what? The mass. in gram. Right there, mass in gram. Nm means what? The molar mass of the what? Of that compound. Molar mass of what? Of the compound. Molar mass of the, which means what? Molar mass of the atom itself. It will be given to you times Q. Right there, Q. Q means what? Quantity of charge what? IT. Then this small letter Q. Remember, here we have big letter Q. Here we have small letter Q. Big letter Q is what? Quantity of what? Electricity. White one is what? Is charge. That is the oxidation state of the what? Oxidation state of the metal that is being deposited. Right there. And I'm going to give you what? A table that will show you each element. There are various oxidation states. So that by the time you are solving question, you already know. You should say any metal, you already know what the oxidation state of that metal. You understand? Because each metal have their own personal what? Oxidation what? State. So it varies depending on what? On the what? Metal. Do you understand? While F is what? Faraday what? Constant. Faraday what? Constant. So if you impute on here, you can also have what? M equals to what? The molar mass, I there, times what? IT over what? Q what? F. Faraday constant is what? Is what? 96,500 coulomb per what? Per mole. So here we have the first formula. Here we have the second one. Here we have the third one. Here we have one here. It's okay. Now this way we have to derive a certain formula. Here, this way we want to derive a certain formula. I want to use on here to derive what? A certain formula. If, for example, now they ask to calculate the mole of the what? Of the substance deposited, or the volume of the substance deposited at STP. How you going to do that? So this way we have to use this formula here. You get? I want to what? Make Q the subject of formula. I want to derive on that formula for you. Make it Q the what? Subject of formula. But I should make Q the subject of formula here. What am I going to get? It's going to be what? Molar mass times Q equals to what? The mass times what? Q what? F. Do you see that? Now let me make this Q the subject of formula here. If I make this Q subject of formula here, I'm going to have what? Q equals to what? Mass, which is what? The M times QF over what? The molar what? Mass. Can you see that? Now what am I going to do here? Now I'm going to arrange this one in a way so I can get what? Mole. So it's going to be Q equals to what? Mass over what? The molar mass times what? Q what? F. Right there. So remember, in stoichiometric calculation, mole equals to what? Mass over what? Molar mass. Do you see that? Mass over what? Molar mass. So what happened here? So my Q is going to be what? Now instead of putting mass over molar mass, because this also is liter M. Just this here. M. So what to be what? N Q what? F. Q equals to N Q what? F. The what? Quantity of charge equals to what? Numbers of mole times what? The charge or the shell state of the metal times Faraday what? Constant. So this other formula here that is very useful when you are solving question. So going to be Q equals to what? N Q F. Can you see that? See, like what I told you, I'm going to show you how you can solve problem using this formula here. So you don't have to bother here because I'm going to solve a lot of problems. Okay, so you want to stick to the end of this class. Very important. Now, another thing here is that this is when the quantity of charge was given to you. Now they say you will calculate the mass of mole. You know what your shell state and your Faraday was constant. You get that. So you can easily use this formula here. Like what I told you here, I'm going to show you how to solve problem with it. So make sure you keep watching so you understand this here. Now, another thing I want to show you is that because sometimes they ask you what is the volume of substance deposited at STP. Idea. What is volume of substance deposited at STP? Now remember, when it comes to what mole concept calculation, you know that mole equals to what? Volume of what? Of substance over what? 2.4 dmq. Right there. We have this formula for us for mole. Right there. Volume of the substance over what? 2.4 dmq. 2.4 dmq means what? Volume at what? STP. Just a volume at STP. So remember, Q here is equal to what? NQF, which we have already derived already, right? Now, in the place of what? Of this one here, I place volume of substance about what? 2.4 what? dmq. So it's going to be Q equals to what? Volume of what? Of substance over what? 2.4 dmq times what? Q what? F. Now, if I should make this guy the same formula here, volume of substance here, volume of substance, volume of what? Of substance is equal to what? Q times what? 2.4 dmq. Is okay, let me just demarcate this one here. Over what? Q what? F. Very important. So we now have another formula here that says that volume of what? Of substance is equal to what? Q times 2.4, right? Over what? Q what? F. That is it. So we now have all these formulas here to solve questions. So now the next thing here, we want to start looking at how to solve the various questions. So let's get into it. Okay, now so let's start looking at some critical questions. Like what I told you here, we'll solve close to 50 to 20 questions, cut across every aspect of what Faraday first law, so that I can explain to you how to use this various formula to solve problems. Do you understand? I really want you to master this topic with this video. Do you get that? So now we have this question on the board here. But before we solve this question here, now let me show you what the various metals and their what oxidation state. Remember I said that it's only that means what the oxidation states, oxidation what states. So each of these elements have their own various what oxidation states. Here we have potassium is +1, sodium is what +1, calcium is what is +2, magnesium is what is +2, plus aluminum is what +3, zinc is what +2, iron is what +2, selenium is what +2. Okay, tin is what +2, lead is what +2, copper is what is +2, mercury is +2, silver is +1, gold is what +3. So these are the metals and their what various oxidation states, and these are the ones you're going to see. Do you understand? So with that, so I want to copy these formulas and these things in your note, because this is what you're going to use. You get. So now let's start the first question here. Is that given the electrochemical equivalent of metal as 4.8 exponential minus 4, calculate the mass of the metal that we deposited when the current of 4 amperes is passed for 130 seconds. Very easy. So if I solve any question here, first of all, write out all the parameters. Just I've already given you a bank of what formulas you can make use of. So let's say you will calculate what the electrochemical equivalent. Electrochemical equivalent is what is Z. So we are calculating what Z. So let me put this in here like this. Z. Now the okay, so the electrochemical equivalent is what is 4.8 exponential what minus 4. No units. Calculate the mass of the metal. So you are calculating your mass of the metal, right? Now they give us the current I is what 4A. Can you see that? Then my time is what 130 what seconds. So now which formula are we going to use here? We are going to use this formula here. MZIT. This formula we have to go to make it up. Easy. So once you see the question, write out the parameters. That is, you know the word formula to make it up. So here we have my M now equals to ZIT, right? Z is what 4.8 exponential what minus 4 times I is what which is what 4 times my time is what, remember time has been in seconds, so it's already in seconds. It's going to be what 130. So let's use our calculator to what solve it. So you have 4.8 exponential minus 4 times 130. So you have 0. So the mass going to be what 0.2496 what gram. That is it. That is your answer. So now let me give you the one for you to try. Imagine if I should change this one here to 5.7 exponential minus 6, right? And the it says you calculate the mass that will be deposited. You have you have 3.1 amperes, and you have 100 seconds. Go ahead and solve this one for me. Leave your answer at the comment section. This is going to be try one. So let me pause the video and leave your answer at the comment section. Do you understand? I want to see what you can do. So let me do question 2. Okay, now let's look at what the second question. So a copper sulfate solution is electrolyzed using platinum electrode. A current of 0.13 amperes is passed for 2 hours. How many grams of copper are deposited? So here we have the option here. So here we have the atomic mass of what of copper. Here we have the Faraday what constant. So it's very easy here. So let's do these things together. Let's solve it together here, right? So divide this one so that can contain here. Now they say that copper sulfate solution is electrolyzed using planted electrode. A current. So here my I was given to me is what 0.193 watt amperes, right? Is passed for how many hours? 2 hours. So my time is what 2 watt hours. I did. Remember, I'm going to convert hours to what seconds. And to convert hours to seconds. And to convert hours to seconds, I want to multiply by 60 times 60, right? So going to be 2 times 60 times what 60. Do you understand? So going to be 2 times 60 times 60. Here we have what 7,200 what seconds. I did. 7,200 what seconds. So that's what my time, right? Now I say how many grams. So you are being asked to calculate what the mass. Do you understand? Now, but if you check very well, they say it's what it's copper. So the atomic mass of copper, which was the molar mass of copper here, is 63.5 gram per watt per mole. I get. Now my charge, which is going to be F, is what is +2. So my Q is going to be what 2, because I'm going to use this formula here. Mass equals to what the molar mass times what Q. Now we are going to use IT mass, molar mass times what IT. So going to be times what IT or what Q what F. This is that. So I know my molar mass here. I know what my I know what my T, right? Now what my Q? My Q is what is 2. F is what Faraday constant. This is that you can say how easy it is. So let's be what the mass equals to molar mass is what is 63.5 times I is what is 0.193 times T is what 7,200 over Q is what Q is 2 times 96,500. Everything 96,500. So let's do our calculation here to see if I want to get our option here. So it will be 60.5 times 0.193 times 7,200, right? Divided by here we have 2 times 96,500. So here we have my M. My M is what 0.4572 what gram. So what will that be the answer? This is the answer here. So you can see how easy it is, right? So now let me change value. Let me change this value here and so I can solve yours for me. So here we have 0.118. Okay, 0.118. Here we have 5 what minutes. Here we have what 5 minutes. So you are trying and what solve for me. I've changed what the value here. So the current is now 0.118 amperes. The time passed is what 5 what minutes. How many grams of copper will be deposited? So that is you have to leave the answer the what comment what section. So that's going to be what question 2. So let me do what question 3 now. So now let's solve question what 3. They say that how many coulombs of electricity are passed through a solution in which 6.5 amperes are allowed to run for 10 hours. 10 hours. So solution here. No, I will solve for that. I will give you one for you to try. Do you understand? So solution here. They say that how many coulombs? So they ask you to calculate what Q. You understand? Now, when the amperes, now my I is what? My I is what? 6.5 watt amperes. So we can just say A, right? Now, the time is what? 10 watt hours. I did. Remember, I have to convert hours to what? To seconds by multiply by 60 times 60, right? So it will be what? 10 times 60 times what? 60. So here we have 10 times 60 times 60. Here we have what? Here we have 36000 what? Seconds. Just so which one formula are we going to use? It's obvious here. Q, because they what they say to calculate. I want to use IT here. So it will be Q equals to what? IT. Q now equals to what? My I is what? 6.5 amperes times my T is what? 36, right? So that is it. So column. So seconds. So going to be what 6.5 times what 36,000. The my Q now is going to be what 234,000, right? Column. That is the answer here. So let's see the one that is the answer. It should be this, right? Because let's explain it in a standard form. 1, 2, 3, 4, 5. Should be 5. Should be 5. But this is the answer here. That we miss 1 0, but this is what is the answer. D is what is the answer. D is what is the answer. So that is number 3. So this is what is the answer. I miss 1 0, but this is the answer. So now let me change value and so I can solve here. If for example you have 8.0 and you have for 7 hours. Oh yeah, try it. Pause the video and pause the video, try it and leave your answer at the comment section. Please, honestly, I say try endeavor you try those things there. They are very, very important. So let's look at what question 4. So now let's look at what question 4. This is what current in amperes will deposit 2.7 grams of aluminum in 2 hours. So here we have the atomic mass of aluminum of which 27, and here we have what Faraday constant with 96,500. So let's solve this question. Solution. Remember, before you can solve anything here, before I got all the parameters, right? What current in amperes? So we are looking for the currents, right? Now the mass was given to us to be what 2.7 grams. So the mass that was deposited was 2.7, right? Now the time is what 2 hours. 2 hours. Right there. So we convert this hours to what to seconds. So it's going to be 2 times 60 times 60, right? So you have 2 times 60 times 60. Here we have 7,200. 7,200 seconds, right? 7,200 seconds. So now let's look at the formulas we are going to make use of here. So we have to make use of this formula here. Now why are we making use of this formula here? Because I know my mass. This is mass given to me. Now my atomic mass of aluminum is 27. Now I know what my time, right? My time, which I've converted to what 7, which I've converted, right? Then this is the I stage I calculate here. Faraday constant. Then what my Q? My Q, aluminum is what is 3 plus. Remember, Q is what is oxidation state, right? So my Q here going to be what 3. So I'm not saying what using M equals to what the atomic mass times what the IT over what Q what F. Now let's make this I itself formula because we are looking for I, right? To make I solve the formula here, we're going to have I equals to what the mass times QF over what the molar mass times what T. Can you see that? So now let's impute our values here. My mass is what? My mass is what? 2.7 times. My Q is what? Is 3 times my F is what? 96,500. 96,500 over my molar mass. Your atomic mass is what? Is what? 27. This is that is going to be 27 times my T is what? 7,200. So let's use our calculator here. So we have 2.7 times 3 times 9. So you have 4.0 watts amperes. That is what answer. So what I'm going to do now, I'm going to what? Change that to what? To calcium. Hi there. I'm going to change that to what? To 3 hours. I'm going to change that to what? 4.5 gram. So I want you to solve this one for me. Leave your answer at the what comment section. It's very important you try all these things here. So that was question 4. So let me to question 5. Look at what question 5 is that what numbers of moles of Cu2 plus will be deposited by 360 coulomb of electricity. So here they are talking about numbers of what moles here. Of course, I'm going to use this one here. Since you are talking about numbers of moles, so I'm going to use Q equals to what? N Q what F. Can you see that? The what I'm going to use. Now they are giving us Q. My Q here, sorry, my Q here is what? 360 coulomb. So Q equals to 360 what coulomb, right? Now this is the one. This is the only thing they give us here. Now my Q here, my smaller accuracy what charge, right? Is what is plus 2, so going to be what 2. My F is what is Faraday conservation 96,500 coulomb per mole, right? So what I say should calculate here, my N is okay. This is what they say should calculate, as easy as that. So if I should make N is subject of formula here we have N equals to what Q over QF. Can you see that? So my N now equals to what 360 over what? My small Q is what is 2 times 96500. So what we want to do here, so we're going to calculate and get your answer. 360 divided by 2 times 9600. So yeah, my N is going to be N equals to what? 1.865 exponential minus 3, right? Going to be what? Mole. So what will be the answer here? The answer is going to be what? B. That is the answer. You can see I can use this base formula to solve questions. They are not actually what difficult the way you thought it's. Okay, now let's look at what. Let me give you on that question here. Let me just say you have 450 coulombs, right? And you have what? Al3 plus. So go ahead and try it for me. Go ahead and try it for me. Leave the answer at the what? At the comment what section. I want to see your answer. So now let's look at what this question here. They say that what volume of oxygen measured at SCP will be liberated on electrolysis of 870 coulombs of electricity here? You understand? Now, if you check very well, say what volume of oxygen at STP. It shows that we are using this formula here. Right there, we are using this formula here. If you check very well, what volume of oxygen is measured at STP will be liberated on electrolysis of 870 coulombs of electricity. So that this is it here. So we're going to use what? Volume of what? Of oxygen here. Right there, oxygen. We want the oxygen gas, say O2. It's going to be what? It's going to be what? Q times 2.4 over what? Q what? F. Do you understand? My Q is already given to me. Q is already given to me to be what? 870 coulombs, right? Now my F is what? My F is going to be what? 96,500 coulombs per mole. Now when I do what my Q here. Now in the electricity of water here, oxygen will be at what? At the anode, right there. And the numbers of electrons that will be lost is what? The numbers of electrons that will be lost is what? Is 4. Right there. Now let me show you the reaction that will occur at the anode. So this is the reaction that will occur at the anode. Is okay. Now this is the reaction that will occur at the anode. The electron loss is what? Is 4. Do you understand? So that's why here is going to be 4. So now whenever I see a question that involves oxygen, understand that the Q is what? Is 4. That's what I'm going to what make use of. You get? So you don't need to bother yourself about that here. So now let's impute our value here. Volume of what? O2 is what? My Q is what? 870 times 2.4 over Q is what? Q is what? Is 4 times 96,500. You get? So let's input our formula in our calculator. Let me input our values in our calculator to get our answer. 870 times 2.4 divided by 4 times 500. So you have 0.05. So volume of O2 deposited at STP is what? 0.050 dmq. That is the what answer. That is the what answer. So let's say here we have what? 900. So go ahead and try some for me. Go ahead and try some for me. So this is the equation you get. So go ahead and try this one for me. Question what? 6. I believe we have solved variety of questions cut across the different aspects of what using what these formulas here. You get. So I believe we are going to end our class at this point because we have already solved majority of the questions. So but this is going to be part 1. The next part of this video is coming up on electricity, where I'm going to solve other what question when it comes to what second law of electrolysis. Then I want to bring some other question here. Just all these videos helpful. Please leave at the comment section that if you leave at the comment section if this video is helpful. Please, I want to hear from you. It's very important here. And those things I've gave to you to solve. And therefore you solve those things. I also leave them at the comment section. Please, we are trying to get to 5,000 subscribers as soon as possible. Kindly like and subscribe. Then also share this video with your friends who you know that they're also writing chemistry in the upcoming JAMB examination. See you in the next video. Thanks for watching.